All right, so point slope form, y minus y1 equals m, x minus x1. That's the point slope form of the line. And I will give you a point like this 4, -2, and a slope like m equals 7, as we've labeled here and here. And then you just plug them in for y1, m. So this gets replaced, this gets replaced, m, and then x1 gets replaced. And then anytime you have a minus and negative, you change it to plus. I do that in my head. You'll probably do that as well. Like when you see a -2 here for y1, you'll just go straight to this step right here. It's always going to be opposite sign. So y plus 2 equals 7, and then x minus 4 because the 4 is positive. That's it. That's it. That's point slope form. When you're given a point and a slope, it's really easy to leave it in that form. We can even what we'll do in like calculus, what we'll do is actually leave it in this form, not even change it to slope intercept. We'll just move the 2 over to the other side, and then we can put it into our graphing calculator that way. So you guys might see it one other way. Just one other way is we might subtract the 2 over and tack it on the end over here, and then it's in y equals form. But anyways, that's the answer. That's what I'm asking for. When it says point slope form, a lot of students get confused between point slope and slope intercept because they're kind of similar, the words used in that phrase. It says a line passes through -3, 6 and has slope -5. What is the equation of the line? Now, we're going to write the equation of the line just in point slope form on this one. So this is my x1, this is my y1, this is my m. So it's y minus what? 6. The 6 comes first. So just remember that. It's the y that comes first. Equals -5, x minus -3. And then you just rewrite it. Y minus 6 equals -5, x plus 3. And that is the equation of the line in point slope form. So if you're allowed to just leave it like that, which some of them they do, then you're done. If they change it to slope intercept form, you might need to do that. Now the reason, well, I'll wait to show you that. There's a reason why we would change it to slope intercept form, and I'll show you that in a little bit. Go ahead and try this one. See if you can write it in this form. So just go ahead and try it. I'll give you just a minute to see if you can plug it in. Actually less than a minute, maybe 30 seconds.
No, I have it. Just you can't see, so I'm letting you.
Run back and forth.
Wait, what are you giving us time for?
I'd like you to try this one right here. Identify x1 and y1, identify m, and then go ahead and plug it in. You get it? Okay. What'd you get? Even simplified form here.
Me?
Yeah.
Y plus 4 equals 2/3.
X minus 8. Yep.
Or,
Yep. That's it. So that's the equation of line in point slope form. All right, it says graphing using point slope form. This is also pretty easy to do. So I'm going to give you the equation of the line in point slope form and ask you to graph it. So now, instead of using the y-intercept as our starting point, I'll say in quotes, starting point, not really a starting point, but instead of starting at the y-intercept, we're going to start at x1, y1. So x1 is the 2, and y1 is the 1. How do I know they're both positive? How do I know that x1 is positive 2 and y1 is positive 1? Write down the equation again. Y 2/3 x minus x1. Do you see the negative signs in the equation? Parentheses around that. See the negative signs here and here in the equation? So if the signs are negative here and here, then that means x1 and y1 have to have been positive. They have to be, if it changes it to a plus, then they are negative. So it's the opposite of that sign. So just be aware of that because of the negatives in the formula. The values paired with x and y, you'll take the opposites of those to get your x1 and y1. So we go to the point 2, 1 and place a dot there. My x1, y1 is 2, 1, and my slope is 2/3. So instead of starting on the y-axis, I'm starting at 2, 1. I'm going to go up 2 and right 3. And I had told you, I think yesterday, it's kind of nice to get more than just those 2 points if you're going to draw your graph accurately. So we could get another point by going down 2 and left 3. I think that's probably enough for us to draw a fairly accurate line through there. So there it is. What's the coordinate we're going to start at on the now you try? And is it positive or negative 4? It's a negative 4 because why? It's a positive here, so we've got to take the opposite of that sign. Yeah. So negative 4 comma 7. So you go to negative 4 comma 7. Scaling small on this one. Negative 4, 7. I think I got it in the right spot. And then we have a slope equal to negative 4 over 5. So give me instructions. Where do I go from here? Down 4. 1, 2, 3, 4. To the right. 1, 2, 3, 4, 5. Good. So instructions, even a little kid can understand if they knew what down and to the right. So from here we go down 4 and right 5 from that point at negative 4, 7. So my starting point is always going to be these numbers. You take the opposite sign of them and you put a dot there. Okay. So I'm at negative 4, 7 is where I start. And then from that point at negative 4, 7, I do what this slope tells me to do, which is a negative slope. I go down 4, right 5. I could have gone up 4, left 5, but I would have gone right off the graph grid there. So. All right, so I'm going to ask you to write the equation of a line in point slope form if I give you a point and a slope. If I give you the equation, you should be able to graph it. Okay, so 2 things you should be able to do so far. It says, what is the equation that represents the line in the graph? So what is the equation that represents the line graph? And we're going to write this in point slope form again. Here we have a point at 1, 4 and another one at negative 2, negative 3. So I've given you the points and I've given you a picture. If I go from here over and then up, what is my slope? It looks like we go over 3 and up 1, 2, 3, 4, 5, 6, 7. So can you give me M based on that information? Yes, it would be 7/3. Yeah. It's the vertical part or the rise over the run. Yeah, 7/3. And it is positive. So there's that part. Now, I gave you more than just 1 point here. We have to just pick one and call it x1, y1. Okay, so let's just call x1, y1, maybe this positive point up here, 1, 4. So if 1, 4 is my x1, y1, then my equation is y minus what? 4 equals, M is 7/3, and then we've got x minus 1. And it's hard to beat that in terms of efficiencies. That point slope form is pretty easy. You just need 1 point, because like especially when you have a slope of 7/3, you remember what we had to do with the mx plus b form? Like when we plugged it in, we had to solve for b and we were dealing with the fractions, so you kind of got a taste of it last time. We're going to do it again here as well. But it says in the last step of problem 3, use the point negative 2, negative 3 instead of 1, 4 to write an equation of a line. So what would the equation of the line be if I use this for x1, y1 instead of what I chose to use with the 1, 4? It would be y. Can you do this in your head? What's going to happen to the sign here when I plug in negative 3? It will be positive. So y plus 3 equals 7/3 x plus 2. Now, you really have to understand, I don't know if you spent much time with this when you saw this, in previous years, but you really need to understand that it doesn't matter which point you choose. As a matter of fact, I don't know if you can tell, but these 2 lines here, equation of this line here, equation of this line here, if I were to graph these, I'd end up with the same line. They are the same line. Even though they have a different x1, y1, they're the same line. I can prove that to you by changing both of them to slope-intercept form, which is why typically, like on any standardized test, they're going to ask you to change it to slope-intercept form, because regardless of which point you use or which method you use, we would all end up with the same slope-intercept form of the line. Does that make sense? So it's like if you simplify this one and you simplify this one, you should be able to end up with the same exact equation, the same m, the same b. Okay, so and this is one of the methods that we might choose to use to find the equation of a line through 2 points. So I'm going to take this one right here. I'll use 2 different colors. I'd like you to do this with me. We've got y minus 4 equals 7/3 x minus 1. And then I'm going to take over here the y plus 3 equals 7/3 x plus 2. And I'm going to solve both of these for y. In other words, I'm going to put them both in y equals mx plus b form. So first thing I do over here, bring down the y minus 4, distribute the 7/3. So it's 7/3 x. 1 times 7/3 is 7/3. I'm distributing the 7/3. That's it. 7/3 x minus 7/3. Then I'm going to do what to get y by itself? Plus 4, even though you don't want to because it's kind of ugly. That's what we're going to do. So it's y equals 7/3 x. Now, think of this negative 7/3 as maybe negative 2 1/3. Can you add 4 and negative 2 1/3 and give me a mixed number for that? Can you do it? It's going to be 1 and some change, right? What's the change? 1 2/3. So let's just leave it 1 2/3. 1 2/3. And we're going to just leave it right there. So the question is, will this simplify to the same as this? Will I end up with the same y-intercept? It's pretty clear that I'll end up with the same slope. I mean, you can see it already right here. Let's see what happens. So I have y plus 3, bring that down. 7/3 x. I always get the question, how do I multiply this whole number times a fraction? What do I do? Put a 1 underneath the 2. It helps some students. That'll work. Just remember, you only multiply the 2 by the top of the fraction. That's it. If there's a 1 on the bottom of this, the 1 times the 3 will be 3, so it's 14/3. If you multiply the 2 by the top and the bottom, you're actually multiplying by 1, not 2, because 2/2 is 1. So don't multiply the 2 by the top and the bottom. Multiply it only by the top. And then if you think about this as 4 2/3, I think that might help. I think. Rather than finding a common denominator, just think of it as a mixed number. Subtract 3 from each side, subtract 3. So if I subtract 3 from 4 2/3, guess what I get? A wild guess. Yeah, 1 2/3, okay? So I wasn't lying to you. You get the same equation, whether you use the 1 4 or the -2 -3. So I wanted you to see that so that hopefully it'll help you to remember that it doesn't matter. I'm sure somebody will probably still ask me, does it matter which point I use? That's a just point back to the Christmas problem. All right. So I know you can't see on your table. Go ahead and write in the following values here: 10, 30, 70, 90. And then over here we have 640, 590, 490, and 440. So just write those in on the side of that black blob you have on yours. So it says the table shows the altitude of a hot air balloon during its linear descent. So descent would mean going down. What equation in slope-intercept form gives the balloon's altitude y at any time x? So here's what we're going to do. This is equivalent to asking you to write the equation of a line through 2 points. Now I realize there are 4 points here. There are 4 points, right? These are like real-life data points. So we're going to just choose 2 because it doesn't matter which 2 you choose. Okay? If the descent is linear and these are all coordinates on the descent, you can choose any 2 points you want. So I'm just going to, in this case, just choose the first 2 points. So I'm going to take the 10 comma 640 and the 30 comma 590, and we're going to find the equation first in point slope form and then change it to slope intercept form because they ask us to write it in slope intercept form. So this is an alternate method from what I showed you the other day. So it works like this. First we have to find slope, which we have to find no matter which method we use. So the slope would be 590 minus 640 over 30 minus 10. So 590 minus 640 is a negative 50. And 30 minus 10 is positive 20. That simplifies to negative 5 over 2. Now that makes sense to me because they said this was a descent. It's going down. So a negative slope makes sense to me. Now I'm going to label the first coordinate here x1, y1. And then I'm just going to plug them in to the point slope form of the line. So I have y minus something equals negative 5 over 2 x minus something. What goes in for the y minus something here?
Negative 640.
Yeah. We're going to keep that sign negative. Yeah, yeah, I know what you meant. It's going to be y minus 640 and then x minus 10. And if they're just asking for the equation of the line, you could leave it in that form. Now they did say they want the equation in slope-intercept form, maybe so that they can plug it into, graphing calculator into software and graph it. So here's what we do to write it in slope-intercept form. We distribute the slope. Let's do this together here. Negative 5 times negative 10 is 50 divided by 2. 25, so you can just do that in your head. It's bad. We have the y minus 640 here, and then I'm going to add the 640 over. So if I add the 640 over to this other side, 640 plus 25 is 665. And so it asks, what do the slope, well, here's the slope, and the y-intercept represent? Let's start with the y-intercept. The 665, what does that represent? Here we have a hot air balloon. We're given these coordinates at time 10 seconds, it's 640. What's that? It's the y-intercept. What does it mean in real life, though? Like, what is this? The altitude that the balloon is starting at before it starts going down, right? So this is its starting altitude. So you're right, y-intercept. This is where the starting point kind of translates over. This is his starting, not point, but let's be a little more specific and call it starting altitude, right? And then his descent goes like this. Negative 5 represents the meters he goes down every, how many seconds here? 2 seconds, right? So he goes down negative 5 meters every 2 seconds. And if you wanted it in meters per 1 second, you would just do the division. It would be 2.5 meters per 1 second, and you might write it that way. I mean, that's usually how it would be written. Yeah. But literally, that's what that means. We'll put an or here, or 2.5 meters per second descent rate. And if you know that, it's real easy to calculate where he's at each second. Like if I say, well, where is he after 15 seconds? You just go 15 times 2.5, right? Or whatever. So if you can get it in a per second rate, that's helpful. It's like miles per 1 hour would be our speed we're driving. All right? So 2.5 meters per second descent rate. And that's the negative is, covered in this word descent. Okay? So we're doing some physics today, a bit of applied math. All right? We're going to skip the now you try. You're going to get to try one of these later on. So just put a little skip in there. Hopefully that one example is enough. That's where we're at. Go ahead and write your summary. So in terms of a summary, you might want to just write down just this new formula that you need to memorize. and maybe just label it. So if you're given a point and a slope, you know, this is the point. So plug in point, and then here plug in slope. And you have to pay attention to, do they ask for slope-intercept form? Because if they do, you need to change it. And if they don't, you're done. But this is what we call point slope form. So it's the second of 3 different forms of a line. We're going to learn standard next time, and then we're going to be ready for our next skill test. So look at standard form. Anything else? You guys have any